Hello friends. So I'm making this video to clarify some of the doubts you guys expressed regarding n contraction. I hope you all remember these two equations for rectangular weir. This equation is the equation of discharge 2 by 3 CDL root 2G H raised to 3 by 2, which happens to be the basic equation. And this is the equation of a rectangular weir when we are considering the concept of velocity of approach. The second equation, this equation is derived from this equation 2 by 3 CDL root 2G H raised to 3 by 2. Now, consider this term L. When crust length is equal to width of the channel, when don't consider this figure now. If crust length is equal to width of the channel, then those weirs are called suppressed weir. For example, those kind of weirs will be like this. If there is a channel like this, and the weir will be like this. Weir will be like this, and the water will be flowing over the weir. Now the specialty is that the crust length will be equal to width of the channel. The crust length will be equal to width of the channel. This is crust length. This is crust length, and this is equal to width of the channel. And those kinds of weirs are called suppressed weir. Now see this figure, these two figures. Here you can see that there are two additional masonry constructions for the weir, and due to these two structures, we can say that the crust length is not equal to width of the channel. Crust length is not equal to width of the channel. Due to these two constructions, the crust length is not equal to width of the channel, and those kinds of weirs are called unsuppressed or weirs. And here we have to consider the concept of end contraction. So end contraction is for unsuppressed weirs, and for suppressed weirs there won't be any end contraction. You have to remember that for suppressed weir, crust length is equal to width of the channel. And what happens due to end contraction? Due to end contraction, the L term in this equation will change to L minus 0.1 NH, where N is the number of end contraction. Here you have one end contraction, and here you have two end contraction. So this equation will change to L into 0.2 times H. L will change to L minus 0.2 times H. So this is end contraction. Now end contraction, velocity of approach, and suppressed conditions. Please don't think that all these are same. These are different terminologies and different concepts. So if in a question they have said that the weir is not suppressed, then you have to adopt end contraction equation. You have to use L minus 0.1 into N into H over here. And if they have said that the weir is not suppressed, and you have to use velocity of approach also. So two different concepts, the velocity of approach and this end contraction. Two different concepts are there. Then you have to add this equation also, and you have to use a bigger equation. I have already given that equation in the class. So if crust length equal to width of the channel, it's a suppressed weir, and if that's not the case, you have to consider end contraction also. Thank you.